Hi, this is Tom, and this video is going to be an introduction to probability, and we're going to do that by examining what happens when rolling a single die and then when rolling two dice. So, in order to do this, we need a few pieces of a few definitions by which to work from. The first one is the sample space. And the sample space is the set of all possible outcomes, the set of all possible outcomes. And we're going to put one more piece here. And the size of the sample space, the size of the sample space is denoted by n. Okay, now let's try this. Oops, oh goodness, I made a mistake. The sample space, put that in there. I was talking faster than I wrote. Now, this is going to be a vocabulary word, the sample space, and we're going to be referring back to that quite often. Now, so if we roll a single die, and we're going to be looking at the most simple of dice, just a single six-sided die, so just a cube, might look something like this, and it has, they call the little dots on the dice, they call them pips. So we're going to roll a die. And what happens when you roll the dice? Well, when you roll a single die, you can get a 1, you can get a 2, you can get a 3, a 4, a 5. Oops, that was an ugly 5. A 5. Or you can get a 6. And notice this. So because there are 6 different outcomes, we say that n equals 6. There are 6 different outcomes. Oh, so I just used this big word, so let's define what an outcome is. So I'm going to go back to my black, and we say an outcome is the result of a trial of a probability experiment. Probability experiment. Now this is kind of funny because our defining outcome brings us another word that we need to define. Probability experiment. But I know that I'm putting the die before the definitions, but part of that is because we have an intuition about what's happening. So now we're going to formalize that. And then again, so our vocabulary word here is an outcome. And then we say the next one is a probability experiment. Whoops, I think I messed up my spelling quite a bit. A probability experiment is a chance process. A chance, or you might hear the word random or random. Random process that leads to well-defined outcomes. outcomes or results. So in the problem, and again, probability experiment, that's another one of our new vocabulary words today. So when we rolled the die, the probability experiment was actually rolling the die, and the outcome was what happened as a result of that experiment. So let's draw a few little lines here. We'll do a green. The probability experiment here was this. It's rolling the die. And the outcomes are the result of the probability experiment. In this case, it's the numbers of 1 through 6. Those are the well-defined results that we expect, or the well-defined outcomes that we expect. Okay, now, for example, let's do this. Oh, my battery is running out. We have enough time. So what now? The next piece for probability is to actually define it. And we say that the probability of x, this is an outcome, equals the number of desired outcomes divided by the total possible outcomes. And now notice that we already defined the total possible outcomes. That's just our sample space. And so it's just our sample space. And we would just say n. Now, let's do this. For example, let's set up a little table. It might help us to track this. We have x. X is what happens, our outcomes. And so if we roll a die, we can get 1. I'm going to set this up so it's easy to see. A 2, 3, a 4, a 5, or a 6. And then we say that the probability of those outcomes is this. Now, how many ways can you get a 1? Well, there's only one possible way. So you would say the probability of a 1 is 1/6. The probability of a 2 is also 1/6. Oops. is also 1/6. And as a matter of fact, each one of these has a probability of just 1/6. For example, you might write the probability of a 1. You could write it as the probability of x equals 1. Or you might even just see, if you know you're talking about dice, you might just say probability of a 1. And it equals 1/6. Now, there's something to notice, and that is that the sum of all of the probabilities, it always has to add up to 1. So we need to check this is true. If it's not, we made a mistake. So check that this is true. Okay, so let's try. So let's see the sum. I know this is fancy math notation, but it's just a faster way of, instead of writing the entire sentence, it would say, add up all the probabilities. So I'm going to be really formal so we can just be exposed to it. The exposure helps. So all the probabilities, well, you could get the probability of a 1 plus the probability of getting a 2 plus, I know there's a lot to write, but we'll see this. The probability of a 3 plus the probability of a 4 plus the probability of a 5 plus the probability of a 6. And we know that the probability of each one of those is 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. So if I add all of those together, I would write this as 1. I have a common denominator, so I can very simply just add up the numerators. So I have 1 plus 1 is 2 plus 3 plus another one is 4, plus another one is 5, plus another one is 6. So I could say that the sum of my probabilities is 6, 6, which is simply